Okay, hello everybody. We're going to start proof for the first time in the year. This is something that's deeply embedded in geometry and something that we got to be able to do. But we're going to start out today with relating proof to something we already know, not geometry proofs, but algebra proofs. So let me go ahead and tell you what a proof is and some of the properties that we're going to need, and then some examples. And then you got an assignment that's posted that you should be able to work out if you understand what we're doing today. First of all, what is a proof? What is a proof? So a proof it's really an argument. An argument that uses logic, like we've been learning, postulates, definitions, other theorems, to show that a conclusion is true. So you are showing somebody step by step that something is true. Okay, so to do some of the proofs today, we need the following properties of equality. So these are properties of equality. And the first one is the addition property. You've been using this ever since you started algebra to solve equations. And that just says if A is equal to B, then A plus C is equal to B plus C. So in other words, when you add something to both sides of an equation, you're using the addition property of equality. Similar to that, we have the subtraction property. And that just says if A is equal to B, then A minus C is equal to B minus C. So in other words, you can just subtract the same thing from each side of an equation as you solve it. So you've done that before. We also have the multiplication property. And that property says if A is equal to B, then A times C is equal to B times C. So in other words, you can multiply both sides of the equation by the same number. We also have the division property. And the division property says if A is equal to B, then A divided by C is equal to B divided by C. So you can divide both sides by the same thing, same number. We have now probably the easiest property we have, and that's called the reflexive property. And the reflexive property just says any number is equal to itself. A is equal to A. And we have the symmetric property. And that says if A is equal to B, then B is equal to A. So in other words, you can just switch the sides of the equal sign of the two numbers or variables or whatever you have, and it's still true. Then we have the transitive property. And the transitive property says if A is equal to B and B is equal to C, then A is equal to C. So those are, oh, there's one more, sorry, substitution property. Substitution property. Says if A is equal to B, then A can be replaced by B. So in other words, if two things are equal, they can replace each other. Okay, so let's do our first proof of the year. So this is going to be a 2-column proof, and that's our preferred method of proof. There's other ways to prove things, but 2-column proof is a way to organize your work. And so on one side, you have your statements, and on the other side, you have your reasons. And the rule in your proof, the rule of proof of a 2-column proof is every statement has to have a reason to go with it. So we're going to do some algebra here. The first statement is -5 equals 3n plus 1. What's the reason for that? Well, it's given. Normally, your first reason in any proof is going to be given. Okay, now we're going to solve for n. That's our job, is to solve this for n. And give reasons every step of the way. So solve for n. Okay, so next we might subtract 1 from each side. So that would give you -6 is equal to 3n. That's our statement number 2. Reason number 2, subtraction property. Do not write, if you try to abbreviate SUB, we won't know whether you want subtraction or substitution. So you want to write out SUBTR or something. If you want to abbreviate it a little bit, that tells the difference between subtraction and substitution. Okay, so if you're solving this equation for n, you're going to divide by 3. Okay, so divide both sides by 3, so you use the division property. And then maybe you want to reverse sides and just write that as n equals -2. That's just kind of an optional step there. But That's the symmetric property of equality. Okay, congratulations. You just survived your first proof. And that's kind of what we're going to do, except we're also going to do it with geometry. So let me give you one geometry proof, which is really not much of a geometry proof. It's more of an algebra proof than geometry, but it involves geometry. And that is this one. So let's say that you have a line segment. And the line segment is Km. You got a point in between somewhere, so that's going to be point L. KL is going to be x plus 3. LM is going to be 2x minus 1. And the entire segment KM is going to be 5x minus 4. Okay, so our job in this is to solve for x. That's kind of like what we're trying to prove, is solve for x. So again, we're going to set up a 2-column proof. With statements and reasons. And remember that every statement must have a reason that goes with it. Okay, so statement number 1 is, I'm going to say that KL, the length of segment KL, plus the length of segment LM equals the length of segment KM. Reason? Segment addition postulate. Oh, we're using something we learned earlier. That happens a lot this year. We can write that statement number 1 because of the segment addition postulate. Okay, statement number 2. I'm going to put in for KL x plus 3. Then I'm going to put in for LM 2x minus 1. And then I'm going to put in for KM 5x minus 4. What's my reason for being able to do all that? You heard me say put in, so I substituted, so it's substitution. Substitution property. Okay. Next, I'm going to write for statement number 3. Looks like I have 3x plus 2 on the left side equals 5x minus 4. Reason? Simplification. Or like terms or something like that. Okay, what's my 4th statement? I'm going to subtract 3x from each side, so that'll give us 2 equals 2x minus 4. So what did I do? I subtracted, so it's a subtraction property. Okay, solving for x here. Add 4 to both sides, so I get 6 is equal to 2x. Well, we added 4 to both sides, so that's the addition property. Okay, we're solving for x, so we got another step in our proof. Step number 6 says, so 3 is equal to x. I think you know the reason for that. You divided both sides by 2, so division property. And then we can go ahead and write x equals 3. So we just switch the sides, I should say, of the equal sign. That's a symmetric property. Okay, so there you have it. We proved. I guess we didn't really set out what. We solved for x. So we solved it for x, and we gave 7 statements and 7 reasons along the way. So there you have it. That's your first geometry proof, which is mainly algebra, and then a little bit more, and then that'll wrap it up for the notes. Let's talk about properties of congruence. We've already had properties of equations. Now these are properties of congruence, but they look similar. Properties of congruence. Well, these are going to look familiar to you. You got the reflexive property. You're thinking, well, we already did that. Well, we did it for equality. It's also true for congruence. So we can say that segment EF is congruent to segment EF. So a segment is congruent to itself. Just like numbers are equal to themselves by the reflexive property of equality, segments can be congruent to each other by the reflexive property of congruence. It's one of those fussy details we talked about earlier in the year. Symmetric property. So if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. So that's when we just switch sides, but this time it's not an equal sign, it's a congruent symbol. So if angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1. That's a symmetric property. We also have the transitive property of congruence. And that says if segment PQ is congruent to segment RS, and segment RS is congruent to segment TU, comma, then segment PQ is congruent to segment TU. So the first item is congruent to the second item is congruent to the third, and so that means the first item is congruent to the third by the transitive property of congruence. And now to wrap this up, I just have a few examples to see if you can recognize these properties in action. First example is which property do we use for the measure of angle 1 equals the measure of angle 1. Okay, that's the reflexive property of equality because you got an equal sign there. So reflexive property of equality there. Second, segment XY is congruent to segment VW. So segment VW is congruent to segment XY. So notice that all we did is switch the sides of the congruent symbol, and it is congruent, so it's a symmetric property. The symmetric property of congruence, not equality. Slight difference there. Okay, I got a couple more. Angle ABC is congruent to angle ABC. So something is congruent to itself. That's a reflexive property of congruence. So number one is the reflexive property of equality. Number three is the reflexive property of congruence. And our last example today is angle 1 is congruent to angle 2. And angle 2 is congruent to angle 3. So angle 1 is congruent to angle 3. So the first angle is congruent to the second angle is congruent to the third, so the first angle must be congruent to the third. That is the transitive property of congruence. I would say, okay, so to kind of summarize what we talked about, we're getting into proof slowly. Starting out with proving algebra equations. We went through properties of equality. We saw a two-column proof that every statement must have a reason. We also talked about the properties of congruence and how these properties and definitions and postulates and theorems are all used together to prove a point, to prove what you're trying to prove. And that's where all this is leading. And this is just kind of the first step into that. The next lesson will be geometry proofs. Well, we'll get more into that. But this is just your first introduction. Okay, very good. Thank you for your attention. And let's try some of the exercises.